you stupid? Hacksaw by Carl and Rangel. We used computers and the book to make it.
Not built.
Read.
Specific. Read the new special techniques. It's supposed to be vision mechanics 2.0 to create a electric hacksaw that has a moving arm and a place by angle.
In these next 4 days, we will be able to make a hacksaw and juice it up.
Attainable. Resources to we have to reach our goal at TKIT 2.0. But prior knowledge to we have to help reach our goal, we have used one of these kits 2 times before.
Well then, we are creating this because we like hacksaws.
And this, we will reach our goal by day 5.
So,
Oh, yeah.
oh yeah. Is that hot?
About our technology.
Our technology is Fisher Techniques. It was invented by Arthur Fisher, a German scientist who also invented the expanding wall plug. It was first released to the public in 1965 after he gifted some of the kits as novelties to other companies who bought from him. And they loved it. Fisher Techniques is a building/engineering company that makes kits where you build electric motor powered devices for hacksaw. And the one we used was Fisher Technics Mechanics 2.0.
Really are launching to the real world. Our hacksaw is great, little hard because it ran on a 9-volt battery. The real hacksaw runs on very high electricity. Our project is a plastic hacksaw that doesn't have that much power. The real world hacksaw cuts metal. Whatever it comes.
Well, what problems did you have? Explain the problems you had. How'd you solve them? We had some problems because we were trying to modify it and it didn't work. We fixed that by swapping our gears and other things on the hacksaw. We added some pieces so it helps keep it together. When we added more pieces, it made it more sturdy. We didn't have much problems because the hacksaw was easy. We would try to modify the hacksaw, it didn't work, so we didn't modify it too much.
What did we learn? We learned that hacksaws require multiple pulleys and or gears to be efficient. We also learned how real hacksaws use clamp to hold the thing you are going to cut in place. Yet another thing we learned was that real ones use saw blades with smaller teeth than larger saws. Hacksaw blade teeth are smaller, so they do not catch on metal and bend.
What we learned? We learned that hacksaws cut anything. We learned if we wanted our hacksaw so cut wood, we would have to put a blade or sandpaper on it so it can cut wood.
So cut wood.
But we learned that they hack. There's supposed to be pictures on it. That hacksaw can cut metal and wood, but the metal is less efficient. So when it cuts wood, it takes slower, and because wood it is slower, it takes more time. Conclusion.
Go back and read your SMART goal. Honestly, assess your final outcomes compared to the goal that we finished in 1 day because we started early. Did you achieve your SMART goal? If not, why? We achieved our goal because our project is finished and it's time modified. Would you just launch your grant? If so, what would you change? Yes, because mission magnets is easy and all you have to do is build and modify. What did you like about the launcher? That is used for cutting materials. And my grandpa has range relief.
Oh my God.
What successes did you have? We had a success of a project work. What was something new that you learned? We learned how to make a hacksaw and how it works. How did you and your partner work together, if you had a partner? We worked together and split the work equally with what we did. Describe other details about your launcher and the process of your project. We started and early and we finished early because Carl started and I couldn't stop.
Fog 6, 7.
The steering?
No, we don't have to read
In
it.
the big 2-6.
I could, no,
8, 2, 6.
We picked 6.
We picked 6, yeah.
Oh, that's cool.
At least we don't have to
Hey,
go
we gotta
back.
show them a hacksaw color.
No! No, no, no! No, 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 no!
See now, our,
It is our.
Tony?
This is our hacksaw.
Yo!
oh shoot, I broke it.
Photoshop by Max Recording. We use the internet. It was called Photoshop Elements, Explore Color and Resolution in Photography in L2.
SMART goal. Our challenge, what are you looking at? Our challenge is to explore selective colors and techniques in Photoshop Elements and create black and white images with elements. You will be learning about pixels, comma, bits, comma, and specific notations. Can you say that word?
Notation.
Oh. And applying that knowledge as you adjust an image's resolution and brightness.
Specific. We will use Photoshop or photo elements, explore color and resolution in photography. We will Photoshop pictures of real people. Measurable. In these next 4 days, we will be able to finish Photoshopping people of our choice. Attainable. What resources do we have to reach our goal? We have the Adobe Photoshop app to Photoshop pictures. We're creating this because we thought it would be a tough challenge to do and thought it was cool. We will reach our goal by at least day 2 of our goal.
Our technology. Our technology was used the Photoshop elements to overview on the Smart Lab computers or Photoshop pictures of our choice. We had to use about a day and reread the due page on our launcher for another time to finally figure it out, everything out. We use pictures that have already been photoshopped from the internet for reference. Our challenge was to Photoshop the colors and pictures. I would say that once everything made sense in our heads, the launcher got way easier.
Relate your launcher to the real world. It is used to make colors in real life stand out and make them look better. And in the launcher, it is also used to make things look better. It helps things look way better just by adding a couple touches. It helps you see colors more too. It helps you understand the basics of photoshopping. You can use it for people to help them before and after. Make colors stand out in the launcher. Add a finishing and reality. Add a finishing touch to make pictures look better.
What problems did you have? Question mark. We did not really know how to use the Photoshop site at first. It also took us a while to figure out how to get the picture gray. We had to reread new sliding on launcher.
What did you learn? We learned how to use the bits in our pictures. It helped tremendously with understanding this launcher because it is what most of it is. These are the bits in the pictures.
What we learned, we both learned that the pixels in our picture matter. They are what makes up the pictures to Photoshop. This is a pixel-related picture.
What we learned? We learned the binary code of pictures. This is honestly the hardest part of our project. These numbers represent letters, digits, or other characters in pictures.
What we learned again. We learned how there is math involved in photoshopping. Things like scientific notation are a big thing in photoshopping. This is how the math, use the math to find the dimensions of our pictures. Standard decimal notation. 3900.
What we learned? We learned how to use a histogram to measure the picture. It helped us with finding pictures in Photoshop. And this is a histograph.
But we learned, again, we learned how to use Adobe Photo Editor, an app to edit our pictures. This was the only site we could use. This is the site we use to edit the pictures. Are you sure about that?
Our goal is to finish the project, and we did finish, so we finished our goal. Yes, because we finished the project. No, I would rather try something harder and something new. I like that we got to Photoshop something of our choice. We finished Photoshopping that extra time too. I learned the tools of Photoshopping. We both Photoshopped the pictures. We learned new tools such as the Smart Rush. We also learned what a graphic designer is.
Vocabulary. Oh! This one is blurry and I don't know why.
These are the pictures we did.
This bad.
Or just some of them.
Next we have Dab on the haters.
Gosh, breaking up.
Dab on the haters.
Oh, shoot, why the pictures? I don't know why the picture's covering that, but. Okay, it's supposed to say Fisher Technics Mechanics 2.0. Race and Zach's Fisher Technics Kit and Learning. Longer was Fisher Technics Mechanics 2.0. Heavy loads L2.
Our goal. Our challenge is to build machines that use leverage to lift heavy loads. To be effective, they will need to gain sufficient mechanical advantage. We will calculate the mechanical advantage and determine if we can redesign the mechanics to improve this ratio.
Specific. We will use FT Mechanics heavy loads to create a scissor lift by following the instructions and building it. In these next 4 days, we will be able to. It must have not shown up. What resources do we have to reach our goal? We have the FT Mechanics 2.0 kit, and we have the instructions. What kind of do we have to help reach our goal? Grayson has done this launcher before and has done it this same. We are creating this because I wanted to build it and Grayson wanted to finish building it because when he was counting, he didn't finish. Time-based. We will reach our goal by, we will finish steps 1 through 4 on day 1 and steps 5 through 8 on day 2. On day 3, we will do steps 9 through 12, and on day 4, we will finish any steps remaining. About your technology. We use an FT Mechanics 2.0 kit. We used it to build a scissor lift and modify it.
That picture's ugly.
Yo.
Our launcher is used in the everyday world by lifting heavy loads up by using leverage and strength. It is used to lift objects to higher places. It is also bringing it down. It also brings it down. It is used to safely elevate workers and materials vertically for tasks such as construction, maintenance, warehousing, and installation work. A scissor lift is a mobile scaffolding used to raise people and materials. The platform goes up and down using
Crisscross.
Oh, that makes sense, yeah. Beams that move in a scissor-like way.
Real world scissor lift fully extended. This is our scissor lift.
Not
That
fully-
picture
Not
sucks.
fully extended, but
Stop.
What problems did you have? Problems we had with the steering and the battery were always breaking. The steering broke several times, so it was very hard to fix. It was hard to find a spot to put the battery, so we had to build a platform out to put it. What did we learn? We learned how to solve mechanical advantage problems. We also learned that using a platform, we can put the battery on the platform and keep the lift from getting stuck from the weight of that.
What we learned? We learned using a battery, we can make the lift rise and lower automatically. We learned our lift can't lift much weight, but it can hold it.
We learned that building a scissor lift doesn't take much time, so we had a lot of time adding modifications.
And playing with
We
it.
finished TS in one day.
Oh, he scores!
What we learned making it automatic wouldn't be that hard, but it would set us back by making the lift get stuck at the bottom when rising.
We learned that making our scissor lift would create several setbacks, such as breaking several times and the lift not working properly several times.
What'd you say?
What's
more?
a... Just drew.
Our challenges to the our final outcomes were the same as our goal, except for us adding modifications. We did achieve our SMART goal because we finished the scissor lift and we also found out the mechanical advantage. We would do this mantra again, but probably not change a lot of things because we did about it. I liked how easy it was to make it automatic. Something new we learned was how to solve mechanical advantage. How we did the work with one of us would kind of pieces and the other would build. Our challenge was to build machines that use leverage and lift heavy loads. To be effective, they will gain sufficient mechanical advantage. Calculate the mechanical advantage and determine if you can redesign machines to improve this ratio.
So
The end!
And then
Discard. Oh yeah, and then, no, I want to show it. Since you have the conclusion. This is our thingy.
idiot.
Yes.
And then it rises like this. Move out the way.
Forty.